My name is Friederike Jentoft. I am an associate professor in the Department of Chemical, Biological and Materials Engineering at the University of Oklahoma in Norman. My research is in heterogeneous catalysis. Heterogeneous catalysts are solid materials and that are used to facilitate chemical transformations. Facilitating meaning that we can perform them at lower temperatures and conditions that require less energy, and also the catalysts allow us to only get the products that we desire and not get any side products that in the end will be chemical waste. In principle, there are two approaches to develop better catalysts. One is trial and error. You just take a material, check whether it works for the chemical transformation that you're seeking to do. The other possibility is, and it requires quite some effort, you investigate these materials that are catalysts very closely, and you try to understand how the chemical compounds interact with these catalysts, how they sit on the surface of the catalyst and are then being transformed to the desirable product. And that will tell you what the mechanism of the chemical transformation will be, and it will also tell you what the nature of the catalyst surface must be to effect this transformation. And then you can go ahead and you can make a more rational approach to develop a new catalyst. We call it a rational design of catalysts. And so then we have a target property in mind of our material, and we can try to synthesize that. Well, heterogeneous catalysts in principle have multiple applications. They have applications in industry to synthesize chemicals. They play a large role in making fuels from petroleum, and they're also used for environmental purposes when we think about cleanup of flue gases from power plants, or the three-way converter in hopefully everybody's car. And more recently, we're seeking to develop catalysts that help us to make fuels and chemicals from biomass, which is a multi-step process. And some of these chemical transformations can only be effected when we use good catalysts. So the catalysts that I develop, some of them are actually used for applications that have to do with petroleum conversion, but a large part of the research now focuses on making catalysts for biomass conversion. EPSCoR helped me to a very great extent to build my lab here. I told you before that we need analytical methods to see how the molecules react on the surfaces of the catalysts, and that requires very sophisticated technology, and the EPSCoR grant has put me into the position to buy the latest and finest and get very good data in that way. It also has put me in the position of being able to hire several students who can work on this project. And I think a third very big benefit is, and that has to do with the fact that I moved here just 2 years ago, is it also helped me to connect to all the researchers in Oklahoma to become embedded very well into the scientific community in this state.